Hello students, my name is Dr. Ashish Kumar, Assistant Professor, Department of Chemistry, Patna Women's College. Today we will discuss about the introduction of thermodynamics. In this talk, we talk about the definition, meaning, various terms used, and the importance and limitations of the thermodynamics. The word thermodynamics has two terms, thermo and dynamics. So, thermo means heat and dynamic means motion. So it is a flow of heat. The branch of physical chemistry which deals with the energy change accompanying a chemical reactions is called the thermodynamics. The complete study of the thermodynamics is based upon the three generalizations called first, second and third law of the thermodynamics. These laws are totally based on our human experience. There is not any mathematical proof of these laws. For example, if I say the sun rises from the east, we all know this is a universal fact and there is not any contradictions of this. Same as the law of thermodynamics having not any flaws found till yet. It is totally based on a logical experience. Now we talk about the importance of thermodynamics. Thermodynamics is an important branch of science and it finds applications in engineering, physics as well as in chemistry. Some of the important applications of thermodynamics are: it helps in predicting the feasibility of the process. It can predict whether a particular process is possible or not in a given set of conditions. Like if I take an example of hot coffee or tea which is kept for a long time, what will happen? It will cool after some time because heat will flow from the system to the surrounding. But what about the reverse process? Can the coffee get warm itself? We know it's not possible at all. This is the meaning of feasibility, that is whether such reactions will occur or not and up to what extent. Thermodynamics also helps us in predicting the yield of the product. Certain mathematical relationships of the thermodynamics help us to predict the extent to which a reaction proceeds till the equilibrium is attained. From this, the yield of the product can be predicted. The law of thermodynamics used to deduce some important generalizations of the physical chemistries such as gas equations, law of chemical equilibrium, distributions law, phase law, Van 't Hoff law of dilute solutions, Raoult's law of relative loading in vapor pressure or elevation in boiling point, depression in freezing points. It also helps in generalization experimental results. The law of thermodynamics offers the means by which one can generalize the result of the many different experiments. For example, with the help of this law, equations relating to certain physical properties with variation of temperature and pressures can be developed. Now talk about the limitation of thermodynamics. Although thermodynamics has been proved great help and importance to the chemist, yet it suffers the limitations. Thermodynamics can predict the feasibility of the process, but it cannot predict the time needed for completion of the reaction. That is, it fails to predict the rate at which the reaction takes place. The law of thermodynamics applies only to a matter in bulk. In other words, thermodynamics deals with the large group of atoms rather than the individual atoms. Thermodynamics is concerned with the initial and final state of the system and not with the path by which it was brought in that state. Now comes to various terms which we use in thermodynamics. First, system, a part of universe chosen for our observations. If I work on the blackboard, it is my system. If you work on your copy, this is your system. Surrounding, all part of the universe except system is called the surrounding. So system and surrounding combinedly form the universe. Now talk about the boundary. The real or imaginary surface that separates a system from its surrounding is called a boundary. A permeable boundary allows the passage of both mass and energy through it. A diathermal boundary prevents the passage of matter but allows the flow of energy through it. An adiabatic boundary does not allow the passage of matter or energy through it. System can be closed system, can be open system or can be isolated system. A closed system which can exchange energy but not matter with its surrounding is called a closed system. Examples: water heated in a closed vessel, or you can use the use of pressure cooker for cooking. Open system and system which permits mass as well as energy across the boundary is called an open system. Evaporation of water in an open beaker is an example of open system. An isolated system, a system which neither exchange energy nor matter with its surrounding, is called an isolated system. Such a system is surrounded by a rigid adiabatic boundary. For example, A liquid contained in an insulated thermos flask is an example of isolated system. Now the microscopic properties, a system which consists of a large number of species is called the microscopic systems. The properties arising out of the collective behavior of the bulk of the species are called the microscopic properties. Temperature, pressure, density, mass, refractive index, viscosity, surface tensions, enthalpy, internal energy are the examples of the microscopic property of the systems. The various microscopic properties of the systems are divided into two categories as extensive properties and intensive properties. An extensive property depends upon the amount of substance under considerations. For example, mass, volume, internal energy, heat content, free energy, entropy, capacity are the examples of extensive properties. Intensive property, the properties which are independent of the amount of substance under considerations. So the additive behavior for the extensive property, whereas there is not any additive properties for the intensive property. Density, surface tension, viscosity, surface heat, specific heat, thermal conductivity, temperature, boiling point are the examples of the intensive properties. Extensive property, if expressed per mole or per gram or per unit volume, becomes an intensive property. For example, mass and volume, as you know, it is extensive property, but density, which is mass per unit volume, or specific volume, which is volume per unit mass, are the intensive properties. Molar properties such as molar volume, molar energy, molar heat capacity are the example of some intensive properties. Thank you for today's lecture. I hope you will get a concept of the basic of the thermodynamics.